Hello everyone. In this lecture, we will see the transducers, the types of transducer. Transducer is an element of a measurement system or an instrument. There are different elements of an instrument like primary sensing element, data translation element, variable translation element, data transfer element, data manipulating element, data storing element, data presenting elements. There are different elements that are present in an instrument. Transducer is one of the important element of an instrument which functions as the variable conversion element. The variable is converted from one form to the other form, uh, like one form means from the measurand, the transducer will take the input signal, it will take the stimulation from input signal, and the transducer will convert that stimulation, that signal, into a suitable form which can be measured by the given particular instrument. A data translation element is a transducer. Here it is given as a transducer is a device which senses the physical variable to be measured and converts it into a suitable signal. It can be a voltage or a current. So that is what the transducer function is, to convert from one form of input energy or in the input signal from the physical conditions of the measurand uh, to the other form. Next step. Or a device to convert the quantity or phenomenon to be measured into a voltage or current, which can be observed on an oscilloscope, read on a meter, or recorded on a chart. For example, pressure transducer. So whatever the changes took place, finally we read on a meter, and that can be written, and if you want you can record it. Examples, the best simplest example of a transducer is uh, an ordinary thermometer is the simplest example, where in that thermometer what happens, uh, the bulb, that sensing bulb, will be having a mercury, or a liquid in that uh, thermometer. When we keep the thermometer in an atmosphere of whose temperature to be known, here the input is a heat, that is temperature, and the final converted, that input temperature is getting converted to change in volume. The volume is getting converted. So volume keeps on increasing because uh, change in volume is the thermometric property of that particular object, that is mercury or a liquid. So that thermometer is a example for transducer, where the input data is temperature, and it is getting converted to change in volume. So when the volume increases at final stage, it records uh, the reading. So wherever it stops, that increasing in the volume, wherever it stops, that temperature is recorded. Now here some examples are given: RTD, thermistor, thermocouple, pyrometers. They are all are transducers. You will find transducers as a part of an instrument, or transducer itself is an instrument. It it is possible. Now, types of transducers. There are varieties of types. Uh, Now, see here. based upon the functionality, we have transducers, displacement transducers. These are the types. Uh, uh, Pressure measuring transducers will be having. So based upon the functionality, the transducers are of different types. Next, examples of displacement transducer. Factors on which the transducer selection depends. This is an important point. First of all, we will discuss this. Then after, we'll go to the types of transducers. The topic: factors on which transducer selection depend. Fundamental parameters. This include types of measure, the type of input, depending upon the type of input. For example, here the temperature is the input for ordinary thermometer. In some other cases, that pressure is an input, or air itself is an input, or the movement displacement is that can be an input. So different inputs are there. So depending upon the types of measurement, the transducer is selected. Next, it depends on range of measurement, and it is depending upon the precision and accuracy levels. And it is the allowable non-linearity effects, allowable dead zone effects, frequency response, resolution. Non-linearity effects means the outputs are in a stable form. We should get the outputs. That is a non-linearity effect. Next, allowable dead zone effects. Dead zone means the variables for which a given instrument will not show a response is a dead zone. So allowable dead zone effects, depending on that, we will select the transducer. And the frequency response for number of for how many number of times the given instrument or the transducer has shown the same output, that is the frequency of response. Depending on this frequency of response also, we select the transducer. And resolution, depending upon to what extent it can find the exact solutions, depending on that also a transducer is selected. Next, the second factor on which the transducer selection depends is environment. This includes conditions of ambient temperature. If depending on the ambient temperature, we will select the transducer. For example, again simple example, and this will come under limitations for using any instrument. If I use the ordinary thermometer, I can depending upon the readings, that is 0 to say 110 degrees Celsius. So we cannot use this ordinary thermometer in cold areas where the temperature of the atmosphere recorded as minus degrees Celsius. There we cannot use uh, the ordinary thermometer. So the selection of transducer depends upon the ambient temperature. Corrosive or non-corrosive atmosphere. Corrosive or non-corrosive, it means if the atmosphere is having the moisture content, H2O, or any other vapor, moisture, liquid particles that are available of any other pure substance, other substance, it can be having. So that may lead to damage to the transducer. So you should select that whether it is a corrosive type or non-corrosive type atmosphere. Depending on this, you should select the transducer. For next, depending upon the shock and vibration withstands. If the instrument over which we are mounting this transducer, if that instrument is subjected to some vibrations or the shocks, and it should withstand, we should check that whether it is able to withstand the shocks and vibrations or not. Depending on that also, it is one of the factors on which the transducer selection depends. Next, physical condition. Coming to the physical conditions, room or available space, size of the transducer must be selected. Depending on that, it is one of the factor. Next, we will select the transducer. Next, whether the measurement is static or dynamic. Are we going to select a continuous or a static results, or we are going for a alternative or a change of inputs to get depending on that also we need to select the transducer. Next, the energy depending on the loading condition. So The third point here, it is depending on the loadings. Loading means a part, an extra amount, the amount of energy that consumed by a transducer while converting input signal from one form into the other form. So if it is, you should select the transducer which consumes less energy. If it is consuming more energy, and if that energy is not available with the measure end, and if we are going to use such type of transducer, that will not function, that will not perform its function at that particular area. So you should select, depending upon the energy consumption or loading conditions, you should select the type of transducer. Compatibility with the next stage, this is one of the factors on which the transducer selection depends. Transducer should be so chosen so as to meet the requirements of next stage. Requirements of next stage means impedance matching, excitation voltage matching, sensitivity tolerance matching. So depending on this type of matchings also, or one of the important factors, the impedance, excitation voltage, and sensitivity tolerance. These three are important factors on which the transducer selection depends. Overall, the general requirements are ruggedness to withstand overloads. All of a sudden, if transducer is getting an overloaded, and it should be ready to withstand that changes. Transducer must be ready to withstand that changes. Next, it should have a linearity, repeatability, stability, and reliability, good dynamic response, convenient instrumentation. So that transducer must be convenient and suitable for a given instrumentation, and it should have a dynamic response, good dynamic response. The general requirements. When you're having the transducer with dynamic response, it can be used for static response also. No, stability and reliability. You should say the repeatability, the degree of closeness of measured values is the repeatability. The degree of closeness of the measured values of a measurand by the instrument is a repeatability. So depending on this repeatability, also the transducer will function. Classification of transducers. The transducers are classified into different types. Here, some of the types were described here. Transducers are classified as follows: active and passive transducers. Active transducer, the transducer which do not require any external energies or external sources for the measurement process, during the measurement process. For example, piezoelectric transducer, photovoltaic cell, thermocouples, moving coil generator. See, example, this thermocouple you're having. For the thermocouple, we don't supply any external energy. Like we don't supply any current for the function of a transducer. We don't supply any voltage or any other external powers like ramming or application of some forces. Such type of things were not required for active transducers. Passive transducers, the transducers which require an external excitation energy to provide their output are known as passive transducers. One of the example is inductive transducers. In inductive transducers, we are having LVDT, linear variable differential transducer or transformer. In that case, what happens? We we have to give some electrical supply for primary winding for the functioning of the transducer. So it is a passive type of transducer, and other types Hall effect transducer. These are the examples. So when we go in detail with this, while going through the displacement measurements or any other physical quantity measurements, we will see what is the passive transducer nature. Next, on the basis of transduction principle used, the input variable to the transducer is being converted into resistance, capacitance, or inductance values. Depending on this, the transducers were classified: resistive transducers, capacitive transducer, inductive transducers. Resistance thermometers, potentiometer devices, resistance strain gauge, thermistor, photoconductor cell. They are examples which come under resistive transducer. Capacitive transducer means dielectric gauge. There you will be having some capacitors. The input value is converted as a storing charge. For the storage of the charges, we will use the capacitors. For capacitor, microphone, variable capacitance, pressure gauge, we'll have different examples we will see while we go through the particular topic. Now, inductive transducer like LVDT or the RVDT, reluctance type transducers, RVDTs, differential transformers type transducers. So, this inductive transducers where the magnetic field that is developed in primary winding will cause EMF in the other windings. So it is one of the types of or classification of transducers on the basis of transduction. This is what they are saying, that transduction. So that is why it is divided into three types: resistive transducer, capacitive, and inductive transducer. Other type of classification: primary and secondary transducers. Primary transducers, it is the first element in a measurement system. It senses the physical parameters like temperature, pressure, displacement, force, etc., and converts them into mechanical parameters, usually displacement. There are mechanical type and electrical type. So the primary means the first element in the it is the first element in the measurement system which senses the physical parameters. It senses the physical parameters first, and like temperature, and it converts into a suitable mechanical parameter or electrical parameter. So such type of transducers are primary transducers. Pressure sensing element, diaphragm, bellows, Bourdon tube, they are primary transducers where the pressure either in diaphragm, bellows, or Bourdon tube, the pressure is getting converted into some mechanical form. Now, next, solid rod expansion thermometers, bimetallic strips, cylindrical column of a load cell which converts displacement into strain. Now, the secondary transducer is a transducer which is used as the second element of a measurement system to convert the mechanical the input of the mechanical output of primary transducer into an electrical quantity. So the translation takes place twice here, not single time. In number of times, if the translation of the input energy takes place, then that is a secondary transducer. Example here, they have given strain gauge and LVDT, linear variable differential transformer. In linear variable differential transformer, what happens where with the change with the movement of the core, the EMF induced linked with the different coils is different. That's a difference. So that is coming under the secondary transducer. Analog and digital transducers. Analog transducers, it is a transducer which produces an output in analog form or a form which is a continuous function of time. In analog form, so thermistor, thermocouple, strain gauge, or LVDT, whatever you take, we'll find some voltage difference or electrical by means of electrical readings. We will find the outputs. So such type of transducers are analog transducers. Digital transducers, it is a transducer which produces output in digital form or in the form of pulses. Turbine flow meter, it will give some numbers, digits. So such type of transducers are digital transducers. So transducers itself, there are two types: transducers and inverse transducers. So simple transducers are input transducers. A measuring device which measures and converts non-electrical quantity into electrical quantity is known as a transducer. input transducer, which converts non-electrical signal to electrical signal. Non-electrical signal, like you're having a speedometer, tachometer, sorry, tachometer, which measures the speed here, electrical tachometer. The input is a RPM, rotation, but the output is an electrical signal. So non-electrical signal to an electrical signal is an example for input transducer or a transducer. Potentiometer example, thermocouple, LVDT, moving coil generator. Inverse transducer, a measuring device which measures and converts an electrical quantity into non-electrical quantity, is known as an inverse transducer. Its function is reverse from that of the transducers. For example, piezoelectric crystal. So if you are having if you give an electrical supply to the crystal, you will get some forces coming out of that body, some crystal, piezoelectric crystal. So it is an example. So vice versa is also converse is also possible, but it is given as one of the example for inverse transducer. So these are the type of transducers. Now, when we look at the first slide, measurement of displacement. As per the syllabus, we are having piezoelectric transducer, inductive transducer, capacitance transducer, resistance transducer, ionization transducer, photoelectric transducer, and calibration procedures. Now, piezoelectric transducers, inductive transducers, we will see in this. See the first one, piezoelectric transducer. It is a displacement transducer. Here it doesn't mean that the input is directly the displacement. It may be, this force may be because of the displacement, that movement in the member. Now here this piezoelectric transducer, what is its function is, when a force is applied over a this crystal, piezoelectric crystal, because of dipole moments, some charges are induced in it. You will be having these two electrodes, and electrodes will capture those charges, and that is checked as output voltage E naught. Depending on the magnitude and the magnitude of this voltage, this force is calibrated. In reverse, if we apply some electrical current, if we give some electricity, we will find the movement in this member. So again, it is a reverse, it is possible in this case. So this is an example for piezoelectric transducer. The main parts of the piezoelectric transducer are piezoelectric crystal, and it is covered with two electrodes, and so flat electrodes. So its functionality is, when we bring this transducer near to the force which is to be measured, the converted form of displacement which is to be measured, that is force, and that force is applied over the crystal, and the moment in the that application of the force will create molecular dipoles, and these dipoles in turn will be in search of the charges, and the charges will be created due to their potentials, and finally those charges are captured by these two electrodes, and voltage is recorded in order to calibrate the given force. And it is one of the transducer to measure displacement. So this is the picture for piezoelectric transducer. Here, this is the piezoelectric crystal. It is a part, and this is the main part. On the application of the force, we will find the dipole moments in the crystal. It is the nature of the crystal, and when charges are induced or developed here, they have been captured by the electrodes, and that will be under a circuit. It is given under a circuit, and you can find some voltage difference or potential difference that is recorded, and that is calibrated to measure this force.